All right. Hello, everyone. Welcome. I'm going to begin this stream with a GitHub push to the Active Inference Institute GitHub account, NoOrg. So start this big push, and then we are going to be in the game. All right. First, where we're headed. We are going to be designing cars for butterflies, and we're going to be doing that by orchestrating a ton of different kinds of different agents, LLM and otherwise. It's actually even a lot more general than that. So stick around, find out, and if you're in the live chat, looking forward to your comments and questions. So let's pull back a second. This is Active InferAnt Stream 13.1. It's April 25th, 2025. I'm Daniel Friedman, and the title of this stream is NoOrg is a Real Org. Let us confirm the GitHub is still pushing. We'll reload it soon. All right. Big picture, this is part of some ongoing projects that are related to organizations, documentation, and multi-agent systems. This is open source CC BY NC SA 4.0. Now that the GitHub push has come through, we will reload the repo, which was empty up until now. And we see everything there. So let us start with looking at the outputs from the example. So where are we headed here? We're headed into extremely flexible, bottom-up, vibe-coded, open source, customizable multi-agent orchestration using an enormous repository of different documents and templates and tools. As just one example, and I will look forward to people suggesting more examples in the chat, and we'll do a bunch of them. Where this is going to go is in the example number 8. At the top of the script is the config. So this was about designing an eco-friendly transportation solution for pollinators. To design a lightweight vehicle was the objective. There were some constraints related to toxicity, and the target users are butterflies actually, but butterfly conservation organizations as well. So just to sort of confirm this, I'll wait until somebody makes a suggestion, and then I will modify the project config to be whatever other inventive scenario we want. And where that takes us is we get a few different visualizations. So here's a visualization of the whole workflow. First, the research unit does requirements analysis through LLMs, sends some messages out to the development unit, out to the community engagement unit, budget allocation, all these different rule-based and LLM-based agents that are sending messages to and from each other. And that ends up getting okayed by the board. There's a bunch of different steps. We'll have different examples. And then finally, it results in the marketing department doing some calls to some image generation services for what the final product might look like. So we can kind of pick what type of organizational structure and flow we want, and that is NoOrg. So we will return to how the example works in a little bit more detail. First, I'm going to noorg.md. Again, anyone who writes a comment or an idea or a question in the chat, I will try to incorporate this. Okay. Why NoOrg? NoOrg is not an organization. It's a meta-organization, a way of thinking about how organizations work. It is like cognition is to organization as metacognition is to NoOrg. And that draws a lot from MetaGov, and that's going to come into play later in the stream. So, part 1, NoOrg is not a real organization. It's not an organization. It is a template and a grammar and system for organizations, kind of like how metacognition is about cognition. But at the same time, NoOrg, if you break it up a little differently, not that it's not an organization, but NOO, knowledge, as in new, meets RG, which could be renormalization group, it could be role-playing game, and it is a real org. This isn't just theory. NoOrg is a functioning entity, a living system where different kinds of interaction generate tangible outcomes and structure. The No acknowledges the unconventional, the emergent, the resistance to rigid definition, yet affirms its genuine existence and operational reality. Or as they say, no organization, no organization. No organization, no organization. And this is not an organization, yet, and perhaps, it functions just as one. So after all, was it a real organization? People talk a lot about agents and agents in organizations. However, at the tactical and the operational level, this is coming down to, among other things, documentation, structure, and process flows. We are at a point where, with the qualitative understanding of this and the above, plus a little bit of vibe coding, it is possible to develop some ground-up software packages and paradigms for flexible design, development, and deployment of agents in an open-source fashion that is agnostic of implementation, structure, function, and process flow. Knowledge is relational. The unit paradox. We will look at the units. Here is a quick look at the Obsidian documentation graph of what the unit structure looks like. So when you dispatch those messages, think about these units and all that they have to do. Here's operations unit, one of the core units. And here's all of the documents that are connected with this massive, well-structured, at least in theory, units repository. We're going to get there. What is a unit? What is nation? What is a tool? What is a finite? What is an infinite game? How do we play? How does the map redraw itself? How do we diagram out these different kinds of units and functionalities? How do we explore pattern over prescription and seek an emergent order? How do we come to understand that knowledge lives in practice and this fundamental paradox of the empty center, the donut, the torus? Where and how do duality and recursion come into play when thinking about the sacred geometries of organization, of living systems? How can we use different kinds of interactivity to have this holistic, synesthetic understanding of structure for cyber-physical systems? And where does that take us in terms of a koan-like understanding of structure? Let us go to the examples after briefly looking at what the units are. So here is a Obsidian representation, graphical view of these different repos. We will go into the charter of the finance unit. So here we are looking at it in Obsidian, and here it is in Cursor. So these are all files, and there's a different amount in different ones of them, but they all have some core files like the charter, the index, etc. Let's go to education. So here's the charter of education, and it's written out in plain text. And what that looks like in Cursor, in the education charter, is these double bracketed links. So this is how Obsidian knows that it is in an Obsidian knowledge base. And that gets rendered out like this. So education charter, index of different documents within the education unit. And this can go to an arbitrary level of detail. So let's just start up a new chat over here. Drag over education in the education unit. Comprehensively add sections and documents. For everything, an education unit or department night. So we'll let that process. And the idea with this is they are human readable. There's ways to render in and out of Obsidian knowledge bases, but human readable forms that give these semantic interfaces that are going to come into play in several ways. So at one level, just by having these files in the Cursor repo, when we then go and code something else somewhere else using prompt engineering, then it's going to find some of this information relevant. So that's a very qualitative, semantic, proximity-based approach. Like if we were going to go over to some folder and say, write an education paradigm. And then in the education folder, there's already a curriculum, and there's already these different kinds of things, like AI principles curriculum. So education could host different information on initiatives, their performance indications, different meeting notes that they've had within subgroups or different teams within their unit. So it's like an organizational structure. And all of that is linked up in the unit directory. So here's the big picture of the unit. This is just one way to draw it out. So high-level structure, here's different organizational relationships. Let's look at it in GitHub. Units, unit directory. So in GitHub, the double brackets don't render like they do in Obsidian. It's still there, though, still plain text, part of the PD of plain text. Organizational structure, almost cool. It's like it's redacted. It's like it doesn't really matter which one they specifically are. But you can have detailed relationships with executive, knowledge, corporate, infra, ops, product tech, revenue. Different templates and paradigms for strategy, tactics, and operations. Different information flow. Different unit structure and the way that those link up. And then the dense linking in the hypertext and in the Obsidian form, tables of information, interfaces with different communities, cross-functionality. These can get spun out to the nth degree. And they have all kinds of information that is both at this kind of representation, totally readable, representable, screenshotable by people, also plain text, versionable, like you can version it in GitHub, that's what we're going to be doing a lot of, and then also it can be used for machine interpretability, legibility of documentation, and all of these different kinds of features. So here is what's Claude 3.7 chugging away in the education unit. So here's updates happening in the education unit. So it enhanced the README, made a new structure for the curriculum. Now it's just writing and chugging along, writing different materials for the education. You can add all kinds of features there. So this project started as thinking, well, how can we generalize across organizational structures? How can we, here we are in the units, how can we look at different units and frame their relationship very generically? Kind of like a Linux kernel. The Linux distribution is not necessarily set up with your username and your password and your wallpaper. There might be some defaults, or it might just be a placeholder, but then this can be rendered or deployed, kind of like, again, a Linux kernel for organizations. And it's an opportunity to flesh out some really exciting and interesting things in this generic form. So here's another example of that. Within the security department, we have cognitive security, digital security, and physical security. Of course, cognitive being the most general of them all. And there's only a few documents in here now, but we can start to play around in the security unit. Oh, wait a minute. No playing in the security unit. And start to explore, what does that generic framework for cognitive security in an organization look like? And it's like, as always, it's the generic and the specific, right? Genus and species. Generalizations and minute particulars. So we might draw and abduct or induct or deduct in different ways, thinking about, like, this would be super cool for a research unit in general. What would be their focus areas in general? Or there could be a sub-research area like It could be the taste research unit. So these kind of nested and interacting units give a lot of opportunity to take the generalization right up to and probably a little bit beyond the point of being generic and end up with all of these different kinds of sub and fractal and nested interacting structures. So we will add a education subunit for language learning. Be comprehensive. Be comprehensively. Okay, so that's kind of the unit structure, and I believe that that is some of the utility and novelty in this situation, which is that it's an Obsidian open source plain text approach to representing organizational structures in the generic and in the specific case, using Obsidian as a way to visualize this NoOrg, right? Because it's not an organization. What is it? So all these different connections, and people can look at how different things connect up. And there's the unit directory, all the things that it's connected and draws with. Okay, so that is the unit component of this package. I'll push the GitHub update. Okay. Okay, back to the stream agenda, which I'll just break down as we get through things. So, the unit directory and the markdown relationships was what I began with. Was building this out and just continuing to say, okay, now add a new unit. Now add this unit. Now link these two units. Now add this unit. Now add more within this unit. And just what other units would be relevant. Just keep it going and going at all those different meta-organizational, meta-governance type structures. Let's add a department of metagov. Let's in slow. Let's in units make a new unit with all needed documents and for meta governance, metagov, about fractal and scale free and interacting governance processes within and among organizations. Language learning subunit. We have a language learning folder. It's been one of the most effective augmenters of vibe coding. Has been, first off, the multi-shot agent mode in Cursor, and then improved ability to have situational awareness in the file structure and being able to have new folders get made and make files iteratively, all that kind of stuff. Plugging away on the language learning education unit, metagov is in process. Okay, so the units folder, it's pretty simple in concept, and it can get rolled out to basically the nth degree of sophistication. You can get as many generic or specific policies as you want. Just keep going. You can continue to work off of the org chart, meta org chart / module structure that is currently in the NoOrg repo. Or I think you've probably seen enough, even at this point, just to go into Cursor or whatever and just say, okay, build me a modular meta organizational structure. Roll out every single possible thing that could be relevant for XYZ. And that'll kind of build you what you want at the right level of detail. And tuning in tweaking along the way. Okay, back to the again, third time to return to this, but I started with just the Obsidian repo. There was no code in this repo at all. It was just about, well, if you consider what you consider code, what you consider a code. Only in the units repo. Just exploring. And I thought, okay, well, wouldn't it be pretty cool to be able to start to deploy custom configurations of agents within those units? And that is where it went. So there's a few different other folders to look at. Agents has a lot of information, all of these documents, ridiculous numbers of documents. So here, this Obsidian window is only looking at the units. Now this one is pulled out to the broader NoOrg. So they're both kind of mutating as the metagov files come into play. So here's the broader organization. Slightly different, much larger network, a lot of more standalone files because outside of the units directory, there's less Obsidian linking. Here in the agents, again, top level folder, there's all these documents. And ranging from some of these are Obsidian linked, they're more heterogeneous. Let's look at it in, let's see. So this is like why putting stuff online makes a semantic impact, even if it's hard to get attention of people in the moment. It's like all the work that metagov and people using the term have done. Some of it gets slurped up, used as training data, and that supports later through this kind of airlock of not really citing them. Sometimes a specific citation or URL or person might pop up, but it's using the semantics of how meta-governance was discussed by the people who discussed it. That's how symbols and words work. So here's a charter for a meta-governance unit. And then if people want to configure their own organization, as opposed to this non-existent organization that we keep on talking about, without this or with it, you can have knowledge management, you can have a legal department, or not. But it's configurable. That's kind of the cool thing. Okay, back to looking at the agents in, let's see. So a lot of there's some code in the agents folder, but not that much of that advanced. Here are a large number of agentic semantic coding. So this is like at the meta agent implementation level, all these different kinds of schema, just at the conceptual level. Like if we want to talk about how do we tune performance in multi-agent systems? Just some pseudocode, some different ideas, some different patterns. How do we think about autonomous learning? How do we think about learning architectures, learning systems, different ways? It could be pseudocode, but this is not meant to be executable directly. But again, where's all this going with the vibe coding? Natural language is code, code of law, all of that. And so these kinds of plaintext, which are now happily publicly available in this open source repo, it plays a role. So if someone says, change tracking and make new changes yellow, that's going to move the needle in some little way into who knows how long later. And someone says, make a visualization for change tracking. And that yellow is going to put its little syntactic finger on the scale. So that's what's happening in the system, agent system folder, is different kinds of looser semantics using natural language, but again, heavily human interpretable and heavily machine readable for all these kinds of qualitative interpretable elements of agents. There are guides, just a few of them, but they are guides to different situations where you might want to do multi-agent learning. So here's like a swarm implementation. Some of this refers to some real code, some of it doesn't, but the whole point and what we see is you just say, okay, build it out where it's missing, use this pattern, and go from there. And that will basically get you where you need to go. So guides, examples. Let's look at it in both places. Here are, again, markdown files of different examples of multi-agent behavior. So part of it is like, why state the obvious? But it gives it, if you want to just say, go to the continent, or go to this region, or go to this city block, or go to this nanometer, there's multiple levels of semantic precision. And it's not that more is simply better. So actually having a really elegant, small, concise way to be like, when we talk about task execution behavior, here's broadly what we're talking about. We mean that this is what happens. Or when we talk about learning, this is what we mean. Those are helpful. And then more technical details can always be scaffolded and layered in. Maybe there's programming languages, coding agents, all this kind of stuff we don't even know about. I would highly believe that. So why not work at a level, like a meta-organizational level, or a meta-programming language level, or a meta-linguistic level, that can always be deployed in different ways? What do we mean by coordination behavior? In the communication folder, just a few documents about communication specifically. It's like, you can keep on growing these documents, and then it's, okay, now let's have a subfolder for just monitoring. Let's have a subfolder for just task execution. Keep on growing out and watering and pruning these documents and modifying them as they go. And architectures, which give a few documents that are related to architectural concepts in agent design, like cognitive models. So the next time that there's a new paper or a new social media post or some other kind of cognitive model, it can just get plugged right in here. So it's kind of like a new restaurant opening in a region. It can already be linked into what is the region, what is the kind of food, it's a restaurant, all these background pieces of information that already bring it into this very interoperable system. So that's the agent. Archive has a few different prior tests. Let's see if any of them are relevant. This one was a multi-agent sorting algorithm, just using this swarm dispatch paradigm to do some sorting on different numbers. This one was a test suite that was written to do a lot of the functional testing for multi-agent systems, so looking at task performances, and then it got up to doing the towers of Hanoi. So this is like a team of agents that were spun up and spun down that were playing these towers of Hanoi games. So people see that. That's in the archive. All right. Then there's dist. So this was another approach to writing out different kinds of multi-agent systems. Different ways. There's multiple different frameworks. Obviously, that would be saying the least, that there's many different ways to do multi-agent modeling. So these are just showing that there's a few different ways to have, in this case, JavaScript agents that have different kinds of capacities, different kinds of abilities. That could be augmented, or the semantics could be transferred to all different kinds of settings. That's the dist. And this is a message passing architecture that actually does have some function, but it's not the main one. And last, before we get to the examples of this TypeScript code, is the docs folder, the meta docs, the paradox, the docs of docs. Here is a vast number of folders of documents that some of them have a ton of information, some of them have just a little bit of information, and they are just another way to include semantics related to these topics. Pretty interesting to think about, like, where and how is the folder structure, just the regular computer nested folder structure, sufficient for conveying the kinds of structural and infrastructural and superstructural information that we want to convey? And where do we want to use, like, graphical databases, other methods? So we won't look through all these documents, of course, but they're all up there, and they come into play when you use cursor. Scan the whole repo carefully, then continue to add linked and relevant metagov stuff. So the docs folder has all different kinds of relevant documentation that can be brought into play in different ways. So it can, again, be used at that qualitative level of just like, here is AGI safety. Well then, if you type in something related to that, or something happens related to that, then whatever's in this file is going to come into more play than it would have otherwise. There is a bunch of sections. Let's see if there's any other fun ones. Core documentation, that's the documentation on the documentation on the documentation. Different ways to do automation. The Git is actually a real one. Fract2Git is a fractal Git program. So just tucking away, it's kind of like you're looking through a library, a hyper library of documentation, and sometimes there's a little bookmark, sometimes there's a little pheromone trail, other times it's like, huh, that's a whole functional piece of software. So in this case, the Fract2Git system, as inspired by Prue, of course, is a fractal Git coordinator that spins up and down and makes different kinds of Git operations on a fractal Git structure. So that kind of extends the Git concept to these nested quantum superpositional repos. But it could be anything. But it actually does have some utility. So being able to make repos, spin up, spin down, clone, merge, all those different kinds of operations on fractal Git operations give a lot of flexibility because, again, though it's probably or possibly not the most high bandwidth or high utility representation structure to use the computer nested system, and even though it might not be the exact set of commands that are the most useful in all possible universes like the default Linux ones, there's a ridiculous amount of training data on these kinds of things. So using folder structures and Git plaintext, you get really far and do a lot. So metagov still chugging away. See if there's any other types of documentation that are fun. Different integrations with messaging platforms, or could get integrated to Mattermost, Matterbridge, be able to bridge across different messaging platforms. Some related sections to the units, a lot of maintenance information. So what at this meta documentational level, what are good documentation maintenance practices? That can be specified whether you're talking about documentation for building a car, driving a car, whatever it is. This is the meta on that. And then today or tomorrow, you can send a person, undergrad, code agent, whatever, and say, go to the maintenance folder and do da-da-da-da-da. and all of that screenshot management. We've been in some situations where the proof of screenshot was make or break. It was sink or swim. So having the screenshot management on point, it's like I've never seen it written out that way, but I could see why it matters once it was written out a way. Meta documentation. In the meta documentation is actually quite a large section with information on the information on structuring information, helping provide some meta documentation on this docs folder. Different metrics. So then when a prompt is used, like make it secure, or make it high quality, or make it performance, those can be just filled up with the make it successful, make it valuable. Those are going to be just drawing on the base semantic distribution of whatever model you use, plus whatever indirect context you have in the code base or scope, plus whatever are in these documents. So if you super emphasize that quality means elegance, then that is going to move the needle in that direction. Let's just see if there's any other, then we'll go to the examples. User interface, troubleshooting, training. Just open these up, see what's there, and then we will close Obsidian and work more with the code examples. Get back to that butterfly call. So meanwhile, if anyone watching has a suggestion for something that they want invented through this multi-agent orchestration or a new setting, then chat. Yeah, prompts. This is just kind of, there's a lot of ways to do prompt management, of course, but here, the prompt folder, so then when you write a prompt, or even not, do good knowledge management. And as usual, mermaid diagrams coming in super clutch. Very few tokens, so very easy to make a difference on a text model, and it renders plain text, etc. for high information throughput for people and for visual accessibility. Prompts folder, quality assurance, research, search, security, different security concepts, different ways to discuss it, setting up, software, standards, strategies, systems, system science, more systems, templates. Oh, I mean, it was kind of like just to continue to play out. What does it look like when you keep on nesting templates? Like, okay, well, we could have templates about meeting notes that you can get into more and more levels of detail with templates on just more and more and more. Or not, just use the base probabilistic distribution of the language model, but if the template is in place, you can investigate it and it moves the needle. Testing, tools, training, troubleshooting. All right, that will be it for the Obsidian part. And we will look now at where we got here. Okay, so I'm going to focus on the experiment number 8 and 9. 8 is going to be a 7, 8, and 9 are some of the more sophisticated ones. Seven is and all this goes into the output folder. Oh, all the source code for all of these examples is in SRC. So here's where there's a ton of information, utilities, There's a documentation folder inside of SRC, of course. Core methods, different monitoring, messaging, different patterns, different TypeScript, and some agent types, which can be up to the customer. We'll probably not go too deep into SRC, but let's look at the examples of outputs. So in the multi-unit LLM flow 7, which we'll just kind of pass through because 8 is a little bit bigger. So in this case, open this up in the target. So this was an orchestrated flow. These things are going to happen in this order, and this is the summary of what happened. So the initial prompt that was given to the innovation unit was a machine for counting and behavior. And then this cost, it looks like 67 cents. Not sure if that was accurate. Probably less than that. And that summarizes the entire process. It is first sent from the innovation unit to assess the idea. Then the generation of ideas. So here's the idea generation response. We'll look at this in So prompt is a fixed prompt, and then it gets back, okay, here's Ant scope, Ant monitor, here's different ideas, Ant site, Ant secure, Ant connect. That gets sent, the idea generation gets sent to the market research, security, assessment, and then finally to the board of review. So let's look at the board review. The AntScope project aligns well with our organization's strategic focus on using technology to address environmental concerns, etc., etc., etc. That is then refined with feedback at the innovation unit. There's a technical and a brand planning, and then finally, the final project plan is written out. So all of this was just autonomously orchestrated based on this fixed organizational topology. So final project plan. It's an executive summary with all of the information from the different sections. So that's 7, example 7, the multi-unit flow. Okay, 8 is the one that brings in a few other features. All right. Using cursor? Okay. So as shown a little bit earlier, what this script is going to do is demonstrate combining multiple agent types in a single workflow. There are some LLM calls, there's some rule-based systems, and there's also image generation with different kinds of coordinations. So let us modify this section. Well, first, anyone watching live, write your idea for a project or the context for a project. And meanwhile, we'll just look at the butterfly car design to look at where we're going to get, which is all the intermediates are saved. So here's like the architecture designer. The system prompt is you're a systems architect, system generic prompt. And then the user prompt is design a lightweight aerodynamic vehicle optimized for butterfly transportation and safety. And then the output from the architecture designer is this is the concept. It's in a JSON, so it's wide, but it deals with having GDPR for butterflies, using different kinds of access control and encryption for butterflies. The images folder are where the final prompts are created and then sent out. So here's like the butterfly car, Here's a logo, and here's a systems representation. So let us make another concept just to confirm that it's doing it from scratch. Using Control K just to modify it in line. This is also quite long file. This is over 3,000 lines of code. All right. Update this so it is designing a physical cryptocurrency hardware wallet that must be invisible and waterproof for children. So now it's called Stealth Kids Crypto Wallet. And all I prompted here, using the cursor, was prompting to change these project configs. So it could be a different domain, could be a different user group, different constraints. It has to cost $0 or whatever it is. Then over on the right-hand side, I'm going to just ask cursor to run 8. So it will generate up the codes running. All right, so meanwhile, while 8 is running over there, we're going to look at the example 9. All right, so example 9, here's where the output is going to get to. Let's go to output. So this is the executive summary. This report presents the results of an active inference partially observable Markov decision process, (MPP) model used to analyze temperature changes throughout a narrative. The model was designed to extract temperature information from the story and determine optimal actions based on the inferred states of the environment. So this has information on this. Let's look at it here. Report. So here's belief updating about temperature. Some of these can be fleshed out. But the way that this one works is that a story is defined in natural language in the prompt. And then first, an LLM is going to be called to say, what do you think the temperature was at each beginning, middle, and end of the story? And then the outputs of that, structured outputs from that LLM, end up getting taken as observations for a POM-VP that then runs an active inference algorithm. So this is more of just a two-step program. Got 8 running in the background. So this one, let's also do a little modification. So here in this story, it was crisp in the morning, then the sun was high, so it's kind of indirectly saying the weather was perfect for hiking, neither too hot nor too cold. But in the morning, it was quite cold. Outside, the temperature continued to drop. So it kind of went from like medium to cold, from cold to medium to very cold. Write a new story about an egg frying as the temperature in the room changes. Okay, so 8 is running over there on the sideline. And so it can Oh, interesting. Interesting story. Okay, let's here. Just run 9. There's some document chunking and splitting techniques. So here we are looking at output. Oh, did we save it? Okay. Oh, it's still working in the butterfly situation. This is another a different butterfly. Wow. It's like a spaceship for butterflies. Just like it should be. And we'll see the third one just appear. Butterfly. Alright? It's just because I didn't save it. Not saved. Great. We just changed the prompt in 8. Run it again. So that'll show up in the folder as Stealth Kids Crypto Wallet. Okay. While that's going. Alright, we did the GitHub push. We looked at the outputs from the examples. We looked at the butterfly car design, and now we're making the Stealth Crypto Kids Wallet. Looked over the sections of NoOrg. This is not an organization, what is it? Reviewed the unit meta architecture, talked about the documentation. All right, there's 2 more sections that few more sections. First, I'm going to look at cognicism by my colleague John Ash and explore what happens when we input the concepts of cognicism into this framework. Then we will go to MetaGov and pick one of their projects, possibly the Constitutions, possibly a living manifesto for online spaces, and see where that goes in this NoOrg setting. And then look at any comments in the live chat, and like if somebody wants to suggest another cool product to design or some other funny thing. So here's new active inference output. So let's look at this report. Okay. Let's read this report. Similar, but I think people get it. This is a very useful pattern, though, what's happening in 9, which is taking in natural language and then having LLM do some kind of inference on it, like tell me how many characters are in the story, or how many facts support this versus how many facts support that, or what temperature do you think it is, or how much do you think that would have cost? All those kinds of questions. Not that it necessarily returns an accurate understanding, but first off, you can sample it a bunch of times at different temperatures, and that enables you to get a really good inference on the latent space of the LLM. So you can say, what GPS coordinate do you think this picture is taken at? And so you can resample that a bunch of times to get the underlying distribution of its beliefs about the GPS locations of that prompt, given the context. And that doesn't mean it's accurate, but it does mean that you have made an accurate measurement of that probabilistic system. Okay, now we're outputting the folder Stealth Kids Crypto Wallet. So let's look at the outputs here. Okay, children 6 to 12, secure, easy to use. invisible, waterproof. How? Here's an interesting question. How will it be represented if it's invisible? Children's resiliency, water resistance, security features, digitalization, digitalization. Okay. D and C, water. That's kind of cool because it's waterproof. That makes sense. Okay. Okay. Imagine a traveling magic show. I'm not sure we're going to work with this design firm again, but at least it looks kind of cool. Maybe the whole thing is it's invisible. Awesome. School programs. Abstract. Okay. So example 9 is again a useful pattern for those who are keeping score of using LLM calls to output structured, basically as a transformer, as they are, between natural language or structured information and some kind of output that you know what kind of output you're going to get, and then you can use that as an input to some kind of Bayesian inference or explicit probabilistic model. That's super useful. Tons of ways to use that. And then in 8 is this other pattern of just using sequences of orchestrated. Let's look at the Stealth Kids crypto wallet report. So this was the designing that invisible waterproof wallet. So here was the orchestration pattern. And in this situation, the orchestration pattern is fixed within the example, but you can imagine creating a situation where it's dynamic. So let's just try that. Say, given the functionalities of these two, let's just focus on just the LLM orchestration of this example. Write a new example 10 where there is a config block at the top so that the user inputs natural language for what kind of organization, flow they want to see. We'll see if we can one-shot this. This might be a few steps. And first, an LLM call assesses that and returns whatever structured format you need so that that organizational flow can be implemented using the approach. Similarly with all intermediates saved and the comprehensive org chart HTML visualization with the org chart as prepared after that special first step. Then take in a prompt from second part of the config block. Another variable for what that custom org should do. Okay. Let's look at cognicism and metagame. Let's let that shut in. Okay. Due to the size of the margin, it will be left as an exercise for the reader to learn more about what John Ash is up to, what cognitism is about. Medium's a good place to see his work. I'm just going to see if copying this one glossary document is enough to make some kind of cool example. So, making a new folder, cognitism, glossary.md. Let's see if there's any other blog posts that might be useful. Let's just try it with just the glossary. Okay. Okay. So that's 10. In this folder, templating off of the functional 8. Write a creative, relevant, useful implementation of the cognitism concept. Make it very relevant and flexible and with copious visualizations and animations. Start with the .ts backbone. If you want to make a Python file in the folder for more analysis and visualization and animation, please do so. Okay. All right, so here comes 10, the dynamic org generator, and then in the third of the 3 possible chats that are interesting, let's look at what we could do for metagov. Okay, I don't see where the actual document is. Okay, Constitutions of Web3 might be a good one. So this is work by Seth Bray and Josh Tan. And I know they have a GitHub repo. All right. So here they curated some constitutions from different DAOs and different groups. So just as an example, if somebody wants to pick a DAO, let's do GiveF. Let's do LexDAO, and say we'll have a good legal constitution. All right. I'm going to do something pretty similar. Examples, new folder, LexDAO. New file, LexDAO on Constitution. All right. Now, I'm going to use the same prompt with context. Templating off of 8, write a creative, useful implementation of how LexDAO works. All right. So we got Cognizant plugged over here. LexDAO here. Alright, in terms of tool use, cursor 49.6, mainly using Claude 3.7 Sonnet. I'm also using Gemini 2.5 a little bit. There's some things where it's doing well, but there's a few other times where it was just acting up. Using Obsidian for the markdowns. I'll push a GitHub update. Let's see if there's any other MetaGov project that might be relevant. Alright, we'll do something with Comtech. Alright, all those are plugged in. We'll prepare the field for Comtech. Comtech. I'm just going to copy just Control A, just Comtech website. Put in just a few unstructured pieces of information. And a blog post. Alright. At the bottom. So obviously this information can be structured better just to show that perhaps it doesn't even matter. Okay, getting some errors with calling tools. We'll see if that works itself out. Otherwise, it might just be trying to do too much in one bite. Okay, at this point, I will, while these slowly churn, I will mention that there's different ways to support the work. You could donate at donate.activeinference.institute. You could get involved with the open source development. You could use this and reference it. You could fork it and develop it or contribute to the main repo on your own. We will be having an upcoming series on multi-agent systems design starting next week. And that will be a 1-month design phase about open to all people who want to participate at the Institute. No specific background needed. The meetings are going to be at 16 UTC on Tuesday and 19 UTC on Wednesdays. And it's going to be first a design phase of 1 month to spec out like what kind of a multi-agent system are you interested to be developing. What kinds of agents, what kinds of information environments, what kinds of flows, all those types of questions. And then in June, we're going to move it into an implementation phase. So as kind of shown here, it's easy to get a sloppy design and implementation with basically just kind of natural language prompting or just using NoOrg. But I think over the coming month, we're going to have a lot of really exciting ways to work at that specification level and then have strong ways to go from that specification to a high reliability, very well implemented system. So I would encourage anyone who's kind of piqued by this stream to get involved that way, or if it's after then, just probably still all good. Yep, getting a lot of errors with me calling the edit file, but at least sometimes it's getting through. It's just having to do it in shorter sections. One more piece that doesn't require the LLM. This is a paper that I came across, Notation as a Tool of Thought, by Kenneth Iverson from IBM Research. So a few quotes here. By relieving the brain of all unnecessary work, a good notation sets it free to concentrate on more advanced problems and in effect increases the mental power of the race. A.N. Whiteman. And the quantity of meaning compressed into a small space by algebraic signs is another circumstance that facilitates the reasonings we are accustomed to carry on by their aid. How relevant. And this paper goes into some pretty exciting directions discussing notation and about ways to have information compression and operations through notation. So kind of like Gödel-Escher-Bach, a notation scheme is developed, like loop and floop, and it's used to carry out a few different kinds of things, like imagine manually writing this. But now we can make these notation systems that are just able to blur the line between the symbolic and the probabilistic. And some of these things would take a long time to understand manually, but it would be possible to put this into an LLM and develop implementations based upon that. Like, this would be literally like learning a whole new language. But we could just put it into a file and say, okay, given that this is the language that we speak, let's just see what happens. Notation. This is going to be called Tool of Thought Notation. Okay, all right. Run the dynamic org generator and fix it if anything errors. Okay. Cognicism's in place. LexDAO in place. Let's see if the dynamic generator works for 10. So, of course, this is all happening real time. Unscripted, neither I nor the machine. So, it's more of an experiment to see, will it work? Okay. Quickly over back to notation. Here I'll use the Control K to use it inline, keeping all the information exactly. Structure this perfect. And we could pick a different model. We could use O4 mini. O4 mini is also pretty useful. Well, it's awesome though. It's just a little bit slow. In this document, write up a bunch of well annotated examples of using this notation, guides on using it in different purposes. All right. All right, but once it gets started, then it starts to fix some of that. Okay. Yeah, several errors in that first draft, but now it is going to at least continue to go. Okay. I don't know why it would be in this. Yep, all the L11s are a little slow, but they are getting the job done. Let's try something that might be a little faster. Okay. Takes a few sometimes. But yeah, it could be faster, but at higher LLM cost. Okay, here we go. So Gemini coming through. All right, so structured. Wow. Okay. Using the Control K inline. All right. Okay, something happened. Okay, how do you use... So, more examples. Just sort of just to kind of respect and weave back with the past. These are all like kind of elaborate notation for thinking approaches. All the stuff, GNN, AOS, Cerebrum, all that kind of stuff is like using function with notation in these thoughtful ways. So, agreement engine, a lot of similarities. More of a focus on agreements. Looks like it hasn't been updated in a couple of years. But similar concept, different kinds of organizational flows, and could be revisited in R5 era. Community rule, similarly, could be brought into play. Okay? Calling the system's getting there. This file is 2030, appropriate. That's now 2300. Okay. Visualizations for calling the system. I will take a sip of water, see if anyone writes any questions or ideas in the chat, and hope that these finish. All right. Lexdown is done. Run it to confirm. Okay, update the dynamic example. All good. Let's switch over to Gemini. Okay, going faster. Let's just do a roll. Continue, run it, and run it, and continue to. Okay, maybe it won't happen in this stream. Don't want to stay on too long unnecessarily, but I will have the partial function versions up. It made many other comments here. Okay, maybe it'll get there actually. Okay. It's the epistemic slot machine. It's like one more coverage. So close. Push an update. I'll look at the chat. Update. So ls, tail, add it to the URL list. Okay. All right, maybe we will get there. That's always part of the comedy. Ignore and continue. Okay, that's something's happening there. And here, Something is happening here. Okay? Alright, we could have docked it. Alright, awesome. Alright. Incredible. Actually incredible. Alright, let's do a different organizational topology just to confirm the value. Okay, let's now running. Here we go. So dynamic org generator. All right. So that was okay. Organization description, organization task. We are updating this to be an organization that is literally shaped like a skyscraper. It is like a skyscraper shaped like a lollipop with a bunch of vertically nested layers, and on the top layer it is hub and spoke with 6 connections. The task for the organization is actually, appropriately, to produce lollipops. Okay. Unmodify the config. Run it again. Alright, we'll see if it actually got there. Okay? Lexdow is working. Never give up. Log. Visualization. Okay. 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 Proposals visualizer. So, it is hanging here. Fix that and run it again. You make those changes, please, then run it again. Alright, let's look at the second dynamic org, see if we got the lollipop code. Who represents the Lollipop Guild? Of the lollipop, for the lollipop. They succeeded. Fantastic. Okay. Okay, I wouldn't say that's exactly it. But pretty awesome nonetheless. Let's just see if we can get the call to tech going. Hey, chat. In the call tech folder, based off of it, use and elaborate on that. So it is a new example comprehensively representing home tech from an organizational ergonomics position. Okay, that's now in the improvement phase. Summarize exactly what to do. Okay. Copy that. Okay, Tucker, thank you for your messages. Yes, using cases, absolutely. Let's do that. Case. Or we'll do that as language. Then case. Then organizational case. Comprehensively write up and obsidian late documents about how the linguistic concept of grammatical case applies to multi-agent and multi-organizational unit operations. Make it incredible and relevant and novel. All right. Now run the full process. Yep. Everybody wants to talk about organizational grammar, but how many want to talk about linguistic case? Looks great. Could use Cerebrum, of course. It looks, but it's still generating. It looks like it stalled here. Suss and improve it and rerun. Okay. Let's see if it works there. Yeah, but if anybody in these last few minutes has any comment they want read on stream or just an idea, okay. Okay, Lex Dow is running. Run it with them. Okay. Just gonna leave that one there because it's going too deep into the core code. And we'll let these play out. I'll just give another minute if anybody wants to make a comment or a question. The total cost of the API credits to OpenAI was about $4 for everything today. Could have been cheaper, probably a few different ways, but all of the work to the cursor was, of course, a lot more than that, yet probably much cheaper. Awesome. Alright, next down. Maybe it's generating a very long file. Okay, oh, there it is. Let's see if we can get it. Okay. In closing, let's do in docs, dialogues, we'll do who's on first. $4. Hey, Prue in the chat. $4 API cost for all of these examples that I'm running. So like many dozens, including a lot of the image generation, which is probably takes up a large amount. Here, right, a synoptic, panoptic, all good, all beautiful, all truthful, truly hilarious, who's on first style, vast dialogue regarding all the information in examples. Lex down, still going. Little frozen. Okay, I'm gonna call it there, but as soon as the who's on first comes through. Alright, so with that, we'll just push the last update. Finishing the stream. And then we'll look at the dialogue on docs, dialogues, okay, there it is. All right. Hope this was useful for some, interesting for some. It's definitely been fun to work on, and I'm appreciative you've watched this far and attended to it. It's pretty fun. So, looking forward to people's comments and contacting me and however. All right. Until next time.